2025 A-Level Combined English Paper 2 Part A question number 9. This question has to do with probability and is actually quite easy. The question says, let A, B and C be three events of a sample space omega such that A and B are independent events and B and C are mutually exclusive events. It also says that the probability of B occurring is directly equal to 1/5. So we already know the probability of B occurring within this sample space omega. It also says that the probability of A or B occurring is equal to the probability of B or C occurring. Given this, it says, show that the probability of C occurring is equal to 4/5 of the probability of A occurring, and then it says, find the probability of C occurring if the probability of C given A already occurred is equal to double the probability of A and C occurring at the same time, which is not equal to 0. Now, not equal to 0 bit is there because in order for P of C given A to be anything other than 0, we need the case that A and C can happen at the same time, which is why probability of A and C happening at the same time is not equal to 0. So now, how do we approach this problem? The first thing we can do is to try to line out all of the things that we do know. In this case, we know that A and B are independent, but from this we can actually derive some relationship of probabilities of A and B. Specifically, if we say if A and B are independent, what we know for two independent events is that the probability of the first event happening and the second event happening at the same time is going to be equal to the probability of the first event happening multiplied by the probability of the second event happening. So in this case, the probability of A and B happening at the same time is equal to the probability of A happening times the probability of B happening. Now similarly, for the second statement, B and C are mutually exclusive, we can convert that into a similar equation. So if the events B and C are mutually exclusive, it means that they have no intersections, meaning that B and C cannot happen at the same time. So if that's the case, if B and C are mutually exclusive, it means that they don't ever occur at the same time, meaning that the probability of B and C occurring at the same time is equal to 0. Now, additional to this, we also know that the probability of B is directly equal to 1/5, and we also know that the probability of A or B occurring is equal to the probability of B or C occurring. Now, in order to progress from here, what we're going to do is to expand the probability of A or B and the probability of B or C by using the fact that the probability of any event, let's say X, or another event Y occurring is equal to the probability of X occurring plus the probability of Y occurring minus the probability of their intersection, which is X intersect Y, or X and Y occurring at the same time. And we can clearly see that this is the case if we consider simple Venn diagram. So considering the simple Venn diagram, we can see, this is just a simple proof here, this is going to be A or B, and we can see we have the completeness of A, we have the completeness of B, but then we also double counted this central bit here. So if we just add A and B together, we're going to cover all of this. So I'm going to, let's say we color it with, let's say, red. So if we do probability of A, we're going to color all of this. If we do probability of B, we're going to color all of this, and you can see we have double colored the central part. So therefore, if we want probability of A or B, we have to subtract the double colored part, which is A and B. So due to that, we can see that this identity is going to be true, and if we then use this identity, we can see on the left hand side of this equation, we're going to get for A or B, probability of A plus the probability of B minus the probability of A and B occurring at the same time, and that's going to be equal to, and if we do the same exact thing on the right hand side, we can see we're going to get probability of B plus the probability of C minus the probability of B and C. Now, we can see we have this thing and we have this thing, both of which we know from above. So we can actually directly substitute both of those in to get that P of A plus P of B, but on the other side we also have P of B, so I'm actually going to cancel those two out, minus probability of A intersect B, which is going to be probability of A times the probability of B is equal to, and on the other side we have probability of C minus 0. So we can write minus 0. Now here we can see if we factorize out the probability of A, we're going to have 1 minus the probability of B. So therefore, probability of C, which is what we want, probability of C is equal to probability of A times 1 minus the probability of B. and the probability of B we do know. From above we can see it's 1/5. So therefore PC is equal to the probability of A times 1 minus a fifth, which is 4/5 of PA. And therefore we've proven the first part of the question quite easily, and we've shown that probability of C occurring is 4/5 of the probability of A occurring. Now for the second part of the question, we have to find the probability of C occurring if the probability of C given A occurring is 2 times the probability of A and C occurring at the same time, which is not equal to 0. Now for this, what we're going to use is the fact that the probability of an event C given A occurring is going to be equal to the probability of them both occurring at the same time, which is the probability of A intersect C, divided by the probability of the second event occurring, which is the probability of A. So divided by the probability of A. This is going to be equal to, as we found above, 2 times the probability of A and C. So we have the 2 times the probability of A intersect C. Now we can see, since A intersect C is not equal to 0, we can cancel the A intersect C from both sides, giving us that 1 over PA is equal to 2. So we can see 1 over PA is equal to 2, which implies that PA is equal to 1 over 2. Now of course this is possible because of the fact that the probability of A intersect C is not equal to 0. Because if it wasn't equal to 0, then this thing being equal to 0 and this thing being equal to 0 is a valid solution, and it doesn't have to be the case that 1 over PA is equal to 2. But in this case, since it's not equal to 0, we can cancel it, leaving us with 1 over PA equals 2, which gives us the probability of A occurring is 1 over 2. Now finally, we can use the fact that the probability of C occurring is 4/5 of the probability of A occurring, and say that the probability of C occurring is equal to 4/5 PA is equal to 4/5 of 1/2 is equal to 2 over 5. And therefore our final answer is going to be 2 over 5, and that's going to be the final answer for this question. Now finally, if we consider the marks of order for this question, at the start, when you get this equation, you substitute the fact that the probability of any event A or B occurring is the probability of the first event plus the probability of the second event minus the probability of the two events occurring at the same time, which is probability of A and B in this case, and do the same thing for the right hand side, you get 5 marks for that. When you then use the information you know, which is that A and B are independent, which means this is the case, and B and C are mutually exclusive, which means this is the case, and you go from this line to this line by substituting and get this line, you get 5 marks. After that, when you simplify down to get PC is equal to 4/5 of PA, you get another 5 marks. In the next part of the question, when you use the fact that the probability of C given A is the probability of A and C occurring divided by the probability of A occurring, for this substitution, you get 5 marks. It's not necessarily for this equation, but rather for this substitution. And then, when you simplify down, get the probability of A is equal to half, plug it in to get the probability of C occurring is 2 over 5, you get another 5 marks. And that's going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.